Big thanks for everyone coming out. It's funny, I think this is the third time I've presented here. So I think the first time the Cardinals were in the middle of the World Series, so turnout was like super low. I think the second time was one of those freak kind of November St. Louis ice storms, so turnout was really low. So it turns out really, I guess the trick is just letting people also show up in person or in their pajamas to actually get a decent turnout. So at a high level overline, what we're going to go over is we're going to kind of generally cover the what Pulumi is, kind of why you'd want to use it, kind of comparisons to other similar products out there, and generally spend the rest of the time kind of going through demos, kind of generally showing the basics of how to get started with Pulumi, kind of how to create resources, kind of how to really leverage the strengths of, since it does leverage general programming languages like C Sharp, where you can kind of best use those strengths in Pulumi, kind of how to more scale and restructure your code as it gets bigger, and then kind of also how to work with kind of more brownfield applications as far as, if you already have existing infrastructure out there. So at a high level about me, my name is Jake Adams. I work at Worldwide Technology. Basically, the way if you want to get a hold of me after this, I seem to have the handle Jacob L. Adams at most social media things. So that's my Twitter, my GitHub, my email. If you do need a link to the slides and the code, there's a link. Obviously, you can get it through the meetup things. I think they'll be there as well. But there's just a short link of bit.ly/Jake Pulumi, and that's my Twitter handle at the bottom. When I'm not going through the Pulumi reference docs to get ready for stuff, I do like to run. So that's kind of my distance I've run over the years. You can kind of tell the dip because I also have two darling kids. That's kind of where it took the hit in the running. I will say that spike there at the end there in the last couple of years, that is around when I got into infrastructure as code. So I don't want to make any promises, but I'm pretty sure it was actually the infrastructure of code that doubled my running, not actually some sort of global catastrophe that pretty much canceled all my social activities for 2 years straight. So generally, what is Pulumi? So the tagline you're going to get from the Pulumi.com website is, and I think it actually does a pretty good job, is basically saying that it gives you a way to manage your cloud applications infrastructure, but kind of using the kind of the general practice that you're used to in a regular programming language. So at a basic level, what it's going to let you do is you can write in a language like C# what you want your infrastructure to look like. So in this case, we're going to create a resource group and a storage account, kind of define that, and then Pulumi will kind of take that and then figure out how to actually make the cloud infrastructure at the end of the day. So, and although in this example, we're going to basically go through a lot of things in C# and Azure, Pulumi actually works across a number of different cloud providers. So it'll work across the major three, Azure, AWS, and Google, as well as just a countless other, kind of more niche cloud providers out there. You can actually write it in a number of different programming languages. So all the major .NET languages, it does use .NET Core, but you can also do it in Go, Python, TypeScript, or JavaScript. So, hopefully I've sold some of you, but in general, you will have to go back and basically, evaluate this versus other competing products, and also, probably end up selling this to, other people at your company. You will have to, kind of justify why you're picking Pulumi versus something else. So, depending on where you're coming from, one of the main things, versus just creating your infrastructure in Azure manually is just going to be buying into infrastructure as code in general. So, I guess, brief show of hands from the people that are here, who comes from more of a kind of traditional development background? I mean, that's at least, where I kind of come from. So, for you guys, a lot of these benefits are going to be more obvious because it's the same reason we automate or write code for anything, right? When you write code, it's going to be automated. It's going to do the same thing every time. You're not going to have some human error forget one step. So you figure when I first got into Azure, just even making a Azure App Service and a database and an Azure, putting Azure AD around it, it was about 50 steps. So to kind of go to infrastructure, because at that time, they were kind of the ones that, made all the infrastructure on-prem. So they were also the people that own the Azure environment. Basically just a Word document that was the 50 steps to set that all up. And we got 45 of them right. And then eventually, remembered the other 5 and kind of ran that in our staging environment, found another 5 steps. And then, 2 weeks later, had to do the production environment and do all those steps plus the 5 new ones that we had kind of remembered that we kind of meant to put back into the Word doc as well. So, and that's just a giant pain to have to do that every single time. Like that's a great place where code can kind of step in. It can be that, that repeatable, automatable thing that you can do. It's also just written documentation, and you can use all the leverages, the same things you normally do with source code. You have history, so you can actually go back and look and say, what was my infrastructure like last April? What were the changes I made to this along the way? It's also just faster, I mean, and we'll kind of see in some of these examples, you can quickly spin things up, and you can also just kind of get rid of them when you're done. It's also just kind of nice in case, something were to happen, it is kind of almost a built-in backup system. You don't have to be as, critical about backing things up because you have the state of at least what the infrastructure should be that you can kind of easily roll back out again. So with that being said, there are a number of infrastructure as code tools in this space, and there are kind of pros and cons with each one. So hopefully I've at least sold you to a certain degree on the, not doing it the manual way. But if you are going to do that, at least the cool term I have heard is, just rebrand it as ClickOps, and then you can at least sounds a little fancier. But, probably the main thing that's going to be in the Azure space is this Azure Resource Manager. So it is also going to be a repeatable way that you can do this over and over again. It is just going to work just in Azure. So the one nice thing about Pulumi is that you can take those skills across different cloud providers. You can, and we'll kind of get into that later as to maybe when or why you would want to, kind of span multiple clouds. But in general, you can, at least if you want to, take those skills and re-leverage most of them in AWS or GCP. You're also going to be able to just write in a general purpose programming language. So, if you use something like Azure Resource Manager or even kind of Bicep to Terraform, you're going to be writing in a very specific language for that. Like you're going to be learning a new programming language in order to do that. And obviously another kind of downside to at least some things like Azure Resource Manager, and we'll kind of show an example later on, it's a very verbose syntax. Like it's very much a machine readable kind of format. You can definitely write it, but it's not as user friendly as something. You can definitely see that's kind of why Azure's kind of come out with things like Bicep afterwards, is that it's kind of meant to be more of that human readable kind of programmer friendly syntax. Now, with that being said, there are some trade-offs depending on your environment. So one obvious thing is that, if you do write your infrastructure as C#, you are going to have to understand C# in order to manage your infrastructure. So if your skills of your team are primarily in C#, or those are people that want to learn C#, great, that's a slam dunk. That is, the happy path use case for people looking for Pulumi. But that might not entirely be your background. So I mean, there are certainly backgrounds where it's already an uphill battle to, if it's not really more of a DevOps team that's kind of owning all the infrastructure and the code, if you have more of a traditional operations team that isn't really used to working in code and PowerShell and source control and things like that, it might already be an uphill battle for that anyway. And then especially if you also have to add on learning a full programming language like C#. So that was certainly a case where I was in, and that's kind of where my background is more in Terraform, is that, that was kind of the trade-off, is that was kind of that thing that everyone equally didn't know. So the programming team had to learn Terraform, and so did the infrastructure team. So that's one thing to kind of keep in mind. Another thing is that, at least at this point in time, compared to tools like Terraform does have a slightly bigger mindshare and ecosystem around it. So there will be more, just general examples out there online or training courses and things. But that being said, it is the older tool. So Pulumi is the newer kid on the block. So I do expect that to change over time. And I think Pulumi's also been very smart about a lot of their architecture is able to piggyback on top of what's in Terraform. And we'll actually show some examples of that later on, where you can actually leverage some existing things in Terraform. So I think they've been kind of smart about that, to not necessarily have to reinvent the wheel a lot of times. The other thing I was going to say is that, a lot of times what you run into when there are packages that kind of sit on top of something else is that there's always kind of a bit of a delay. So all of a sudden March 28th comes out, Azure has some new feature that's generally available. A lot of times what you'll see kind of a week or two delay before that's available in the next kind of downstream provider. because obviously then they have to play catch up because, they get the announcement and their developers have to make their changes. So that is largely kind of changing some newer Pulumi packages. So if you go online, and we'll kind of show this later in some of the Pulumi packages, there's kind of two flavors of a lot of the major cloud provider packages. There's what's kind of called the classic package, and those were either built on top of what was in Terraform, or is it kind of more traditionally their developers kind of rolling these things. And what they've kind of since, and that normally you would see that bit of a delay in those features as far as coming out there. What they've since done is they've kind of leveraged more native packages. So what they do is every night they basically scan the public API for something like Azure AWS, and they basically generate their package based on that. So pretty much within a day, as soon as the new feature's out in Azure, that new feature or that new property or whatever is going to be available in the Pulumi package as well, at least in the Pulumi native package. And you can basically see, even while I was putting together this demo, there was 2 new releases of Pulumi that came out that I had to kind of update and stay in time with. So, okay, so now we are finally going to get into the demos. So your first step, let me make sure you guys can see something. Okay, great. Interesting. Huh, that was weird. Anyway, so really the first step, and amazingly now that I actually get that going, the first thing I'm going to do is jump out. The first thing you want to do is you really want to get started at Pulumi.com. So you will have to basically download and somewhere install the Pulumi CLI program. And I'll kind of say install in quotes. It is just a standalone exe, so you can't either just run the native installer, or you can just kind of just have the exe sitting somewhere. A lot of times, especially with tools like this, where I want to make sure that the whole team's kind of running the same version, you can just take that exe and just check it into source control somewhere. That way everyone's using version 1.17 or whatever. So just one way or the other, you basically have to get the Pulumi exe on your machine. So once you basically have that, you can just go into some sort of folder and you're going to, and I guess I should probably also say the first time you run this, you will normally, and this is one of the things where you have the option either way. So basically Pulumi has to store the state for it somewhere. So the default happy path that it's going to give you is kind of storing it on Pulumi servers in kind of a Pulumi account. So that's kind of the path that they guide you towards, and there's a lot of benefits towards that. So if you do that, then basically the first time you would have to run Pulumi login. And their steps will kind of walk you through that. And yeah, you can tell in this case, I'm already logged in, but normally that would kind of kick you to a traditional web prompt. And the first time, if you didn't have an account, you'd have to make a Pulumi account. So it's going to do that. If you're running in Azure, kind of the same thing. So if you're running the Azure CLI and you're running that locally and you're logged into the Azure CLI, it's smart enough to just kind of re-leverage those credentials and re-leverage that subscription. It'll obviously support all the general ways you can access Azure as well. So if you want to use a service principal or generally any kind of common way that you'd access Azure, it will support all of those as well. So obviously when you're running in more of like a CI/CD environment, you would have to use that. You would want to kind of use more of a service count. And it can kind of pick up a lot of these things from environment variables and things as well. But as far as just locally development and getting started, this is kind of the happy path to get started. So basically then you can just run a new program with Pulumi new. Oh, what do we got here? Oh, I do not have anything there. Okay, let me do my notes here. Very picky about having, I think I have a readme.txt file in there. Yep. Pull that out really quick. All right. Try this again. Let me do. Okay. So by default, it's going to give you a lot of the major cloud provider options. So in this case, since we are really running with Azure and C#, here we go. Going to kind of pick a name. We can give it a different name. Keep this one. We'll keep the default subscription, and it'll ask for a stack name. We'll get more into stacks later, but you can largely think of that as kind of a environment, so like stage, production, things like that. So we'll keep that for now. And they will ask for a specific configuration for your specific cloud provider. So in here, we do actually have to pick a location for where we want this. So we'll pick one closer to us. And that's going to kind of basically build out a basic project template. So I'll kind of use the native .NET Core tools. All right, we're ready to go. So what that's going to basically build is it's really just a .NET Core exe at the end of the day. Shouldn't take a bite of my sandwich. So what it's going to do is create a Pulumi deployment based on what's defined in this my stack. So and I also appreciate this because generally the hello world example in any kind of infrastructure as code thing is always just making a basic storage account. So if nothing else from a demo perspective, I love that this is what they already built out. So what it's really going to do is it's going to, this is just regular C# code. And what's going to happen is it's going to run, it's going to run that root program, which in turn runs this program. And at the resulting output is that it's going to kind of watch for, this program will now kind of define what it thinks should be in Azure. And then basically Pulumi will run after that and kind of say, all right, what do you want kind of in Azure and what is in Azure? And then kind of develop a plan to get from A to B. So in here, it's basically going to say, I want a resource group, and then I want to create a storage account, put it in that resource group, and then there's kind of the following options. So we want locally redundant storage, and then you can also specify outputs, and we can get into that later as far as what it's actually going to do with those outputs. But once you have that, you can run Pulumi up. And that's basically what's going to kick that off. So it's going to build that .NET application, and then Pulumi's going to kind of run that .NET application and then kind of look at what's going to be created on the other end of it. And this should hopefully go pretty quickly. And so you can kind of tell it's going to determine what should be created. So obviously this is a brand new thing, so we have none of these things out here. So it's basically saying in order to get from A to B, we're going to need to create all of those things. So then we can say yes, and it's going to go and do it. And like a lot of other CLI programs, there are other command line things we could have given to automatically say, yeah, go ahead and accept that, so it's not as interactive. Same with the Pulumi new. We could basically go and give it all those parameters up front. If we already knew those, we were running more of like a CI/CD environment. So it's going to basically go out to Azure right now, and it is starting to create those. Hopefully this should be within about 30 seconds here. While we're waiting, does anyone have any questions, either on the chat? I guess I can try to monitor the chat, or in person here. I'm not seeing anything over there. Any questions in person? If not, we will kind of go and verify that this is now out in Azure. Okay, so here's a resource group that it created. And this is one I created, right? Oh yeah, here we go. That bit of delay. Here's a storage account. And you can kind of see there's a bit of a disconnect if you look closely. So basically we wanted something called resource group and something called SA for a storage account. You can kind of tell it has gone and tacked on a bunch of random stuff at the end. By default, that's what Pulumi does, and it's actually kind of a good thing. So I don't know if you guys are kind of familiar with how this works in Azure, but at least resource groups have to be unique across your subscription, and storage accounts have to be unique in the world. So even if somebody were, like even if I were to pick, Jake's amazing Pulumi demo, if you were to also run that same code, it would actually fail because we both kind of had that same name if it didn't do that. So it's kind of basically, it's kind of coming up with kind of some random alphanumeric characters, and it'll kind of do that by default. You can kind of override that, and you can kind of more specify a name if you have specific naming conventions. But otherwise, it will kind of give that to you for free, which is kind of a nice feature if anyone's familiar with Terraform, because you normally have to kind of roll that your own. There's kind of an extra random name provider that you need to bring in to kind of make those things happen. So I like that Pulumi kind of gives that to you out of the box. And as far as what this looks like on the Pulumi backend, So this is kind of what it looks like if you're in the Pulumi console. So you can now see there's a concept of projects, and we probably could have watched this as it went along, but for longer deployments, so here's kind of our project that we created. And we can actually drill into this and actually look at some of the things that were created as part of this. And if we would actually have watched this while it was going along, you could actually see it building out in this GUI. And that's kind of some of the nice things you get if you do lean into Pulumi kind of managing all these things for you. You don't have to. You can definitely take this and, similar to things like Terraform, you can store all those files in a local file storage. You can store those in Azure storage. Obviously there's similar ones for AWS and GCP, but that's kind of the happy path that it's going to lean you towards.
Does that cost extra per team or something?
There is a pricing. So yeah, Alex had the question of the pricing as it grows. I think it's kind of the similar pricing model where I think it's free for free for individuals, but then obviously it's like some sort of cost per once you start scaling it out to teams, and they give you better features and enterprisey things is with that as well. But then the nice thing about that is then when we're done, we can run Pulumi destroy. And what this is going to do is this is going to just basically go and tear all this down. And we're going to say yes. And although this isn't rocket science in this case, it was basically a resource group and a storage account, you can certainly imagine in some scenarios where this could be quite a bit of stuff that we'd have to tear down. Also, and Azure's really good about sometimes having extra things that it creates on your behalf that aren't immediately obvious when you go through the GUI. So if you create something like a virtual machine, it's going to make a hard disk. It might make a virtual network. It might make some, application insight sort of things. And if you just naturally go out and delete that virtual machine, it may not always delete those related resources. So the nice thing about this kind of tracking everything that's created along the way is that it will go and tear all that back down. And this also kind of enables a lot of very interesting workflows. So I mean, obviously, you wouldn't want to just destroy your production environment, but certainly your dev or test environments, you can spin those up, very quickly, just operate on them and tear them back down and not actually pay for those resources when you're done. The other thing is it also kind of enables kind of some very interesting kind of even production release workflows. So you don't even necessarily have to deploy over the top of your existing production infrastructure. You could literally just set up a separate stack kind of side by side, kind of get everything set up in this, the second stack, and then just kind of reroute traffic to that and then destroy your first stack. So it does kind of enable new kind of interesting deployment scenarios as far as that goes. Let's see if there's other important notes in my README that I was going to show as part of that. Yep, up, down, stack. Yep, so Pulumi, providers. Oh, that was the thing I was going to show. Yeah, so obviously, I went and deleted it. Well, that's okay, we can go ahead and recreate it. Go Pulumi up, dash yes, skip through that. So basically in this case, we are going to go ahead and create this using, by default, going to set locally redundant storage. So we'll let this go ahead and create about 30 seconds. So the nice thing you run into is if you do these things in PowerShell, and certainly at a former life, it's kind of running the build server and doing a lot of these things more on-prem in PowerShell, that you run into is that, if you go and, the second time you run it, so it's not just saying, I want to create it. It's that, all right, well, actually first check if it's already created. If it is, then maybe keep that, maybe destroy it and then recreate it. Then actually go into the thing that's created, see if it's already set. There's a lot of complex logic that you have to do to kind of get from point A to point B if that stuff's already there. So Pulumi will kind of handle a lot of that things for you. So in this case, we've gone and created all this infrastructure. And instead, if we change it from locally redundant storage to geo-redundant storage, we come down here and we run Pulumi up again, not automatically commit it. So it's now going to basically say, this is what I want, and it's now going to compare what's there, and it's going to realize that most of that stuff is already there. And really, in this case, just like in the Azure console, you could basically just change this. So it's basically saying, you can see it's no longer saying I'm going to create 3 things. It's just saying I'm going to update one of them, and all I'm really going to update is just going to be the SKU. So it's not even going to have to drop and recreate that. It's just going to modify it. So it's kind of handling all that heavy lifting to kind of get from point A to point B. Now, there are some times where there are just big enough changes where the way it does get from point A to point B is just literally by dropping it and recreating it. There are some times that there are just changes that are so massive to a resource that that is the only way to get there. But that is kind of the nice thing about the desired state, kind of defining things in that manner is that, it's smart enough to kind of do those deltas versus just kind of recreating everything. So that's obviously a very simple example. In our next example, we're going to just slightly build on top of that. Kind of drop this back down. So basically what happens is that's just one resource. Once you actually start getting to multiple resources, the nice thing is that you can just, it is just data, so you can just use them like variables as you normally would in C#. So in this case, we're not only going to create our storage account like we were before, but we're now going to create a container inside of there. And it needs to know what storage account it's in. So we can just reference this later on down there. We don't have to duplicate that variable just like we normally would in programming. We'd store that in a variable and we'd reuse that again. So all of a sudden, if I want to change this name, I don't need to rename it down here, especially in this case where it's going to add some sort of random GUID on here. I don't need to be smart enough to know what that is. Pulumi's going to, whatever that name is going to come up with, it's going to just spit it out down here later on as an output. And then kind of that same thing, if we cascade that farther down and actually put a blob of data in there, we can kind of use our resource group name, our storage account name, our container name. And it's also smart enough to kind of know that it's kind of linking these things. So, you can kind of tell when we're building out these graphs, if you look closely in the console before, it was going to try to create a lot of them in parallel. So it's going to try to parallelize as much as it can, but it knows in this case that these things actually have dependencies on it. Since these things are basically linked via variables, it knows not to start creating this blob account until all these other things are done creating. So it's smart enough to kind of build that dependency graph and to kind of parallelize when it can and kind of wait when it needs to. So I won't actually show building that one. I'll assume you will kind of trust me that will actually put a blob out there. But it is kind of worth noting too that there's also the concept of assets in Pulumi. So I will show in the next example kind of a file asset, but this is just kind of the way to actually get the text in there. So this is actually saying just verbatim, this is the data that I want you to basically throw into this blob. But we could also just link it to a file in the local file system and put that binary data in there as well. Okay, so moving on to our next example, what we're basically going to do in this example is we're going to, this is kind of a setup to the next example. So in this case, we're going to, so now we have a storage account. What you can do in Azure is that you can basically set up public access to that storage account. And then from there, what you can set up is you can basically set up basically that public storage account to effectively run as a website. So, I mean, you're not gonna be able to do any clever dynamic things like you can in ASP.NET and generate things on the server side. But if you're just serving HTML and JavaScript and CSS, more of like an Angular type app, you can serve it out of something like blob storage. So that's basically what we're going to do here. We're going to build that static web app. So we're going to set up that storage account just like we were before. We're now just going to set up a few additional things to kind of allow public blob access and enable HTTPS traffic and kind of specify a specific TLS version. That's the nice thing about having this in code too, because a lot of these times these are things that you really should be setting every time, but sometimes the default in Azure will lean you towards the practice that you want to do, and sometimes they won't. So, and we'll kind of show more in later examples how to kind of codify these and abstract these away to where they happen every time. But that's kind of the nice thing about having it written down. Like it's kind of more set that way, and you can kind of set it your standards to meet for your company. But yeah, so we'll now set up a static web app, kind of leveraging those previous variables, and we will set a basic HTML file in there. And in this case, we will just actually hard code in what that HTML should be. And the other important thing is that you do have to set it the right content type, otherwise it will just try to download it as a text file. And then basically what we can do is we will get our, it'll wait until it's actually created and then give us whatever that endpoint is, and then we will spit that out in the output to a console for whatever that URL is. So go here, go to our second example. to yeast. There's no yeast command in Pulumi. And what stack we're using? Dev stack. Okay, are there any questions at this point in time for anyone on what we're seeing so far? Fairly basic example here so far. And really, we probably could have skipped this. Hopefully, you guys will accept that this will serve a HTML file. But this is it's also a pretty quick example as well. Oh, here, we can catch it on the web page. It's gonna take like 30 seconds to create this. I'm never gonna catch it in time. I think it's already created. Nope. All right, let's see. Oops, see it a few seconds ago. Interesting, that's a fun fact. It's actually smart enough to know it pulled some of my GitHub branches and changes on there. So it can actually associate that to a particular branch in my GitHub account. That's cool. See, I'm even learning new stuff. All right, so this is our URL here. Ta-da, amazing. This is the thing that's always fun about infrastructure as code. It's like I literally spent I think 2 hours one night building out a whole Kubernetes cluster to build all this stuff, and then just showed hello world at the end. And I'm like trying to show my wife to be like, yeah, I don't think you understand how cool this was. Like all the infrastructure that is behind it. She's like, can't you just put hello world in an HTML file and like run it? It's like, I mean, you could, but you're missing the point. Like you're not getting how cool this actually is. So once again, this is actually very cool, but at the end of the day, we have a static HTML file that says hello world. So with that being said, this is all still fairly basic stuff. But now the other thing is that, obviously you can imagine a scenario where our website is now actually running a bunch of stuff. So in our third example, we actually have a full website. So it's like, I say full, but it's like, it's still basically a very nice hello world. But once again, though, I mean, just like regular programming things, you wouldn't want to go and then just repeat 20 different things on there where we're saying, put 20 different blobs in there and also actually get, setting the right content types on all those. So this is one of those cases where, just a regular programming problem. And since it is Pulumi and C#, we can solve it in a regular programming way. So in this case, we still have all of our basic things like our storage account and our static website. But now what we're going to do is just in regular C#, we're going to say, go out to this directory info, loop through the files, and for each of those files, just create a new blob. It's also worth noting in Pulumi that you don't actually have to do anything with this variable. Literally just newing it up signals to Pulumi that it needs to be created. We don't actually have to go and take that new blob reference. So if we're not actually referencing it in a dependent resource, we can just say new, and we're done there. But basically, we can go ahead and say new. And then, kind of at first, at a very naive level, I was going and kind of setting the MIME types. And this actually kind of fell down in a couple places because, there were other types that I didn't have other than this. I was just trying to get the demo built. And this is actually a fun thing that I wasn't even thinking about. So I was like, all right, I know that there's other ways you can get the MIME types out there. I know you can basically go to the registry, and there's other ways you can do it. But even the registry thing, it's not really a supported .NET Core way. And basically what's out there is just a standard NuGet package out there that does just have all these MIME type mappings built in for you. And that's another slam dunk for this stuff. So I can literally I just went out and I just pulled in that package as a NuGet package. It's just the MIME type package. And now basically when I am setting this up, I no longer have to put in, where's it at, my limited kind of way. I can just kind of pull in the MIME type NuGet package into this code, and I'm kind of leveraging those best of both worlds. Like I'm writing .NET code the way I'm familiar, I'm leveraging NuGet packages the way I normally would, but I'm also controlling Azure resources and Azure infrastructure at the same time. And I can even really be fancy. Instead of the for loop, I could have written a link statement down here as well. So. It's not really a lot of magical things this demo, but at least it's showing that it does actually pick up all of those things that are in that directory. You can kind of see it is now picked up each of those to actually be created. And it would actually have set all the appropriate MIME types as well behind them. So it's smart enough to pick up the right font file MIME types and the right CSS MIME types. So we'll have to go ahead and create, let's kind of jump on to the next one. I mean, in reality, I think it's a slightly fancier Hello World demo. So I think you guys can trust me on how that will actually get created. So with that being said, sometimes there are some of these things that you will want to vary in certain scenarios. Obviously, just switching between, production and staging. There might be certain scenarios where you want to have, maybe you want to have just more cheaper, locally redundant storage in stage. You do actually want to have geo-redundant storage in production. So there are different ways to vary that. So kind of the concept around that is there's different stacks. So a stack is kind of considered a different copy of that infrastructure. So it's kind of maintained completely independent. So as we were making those changes, you can kind of tell it was going to overwrite whatever was there. If we set a new stack, it would actually kind of make a separate copy of those things. So if we kind of keep our existing example, make sure I'm in the right direction here. Let's see, is this more of a same example? Yeah, it is. Yeah, if I could just create that one. So let's get out of this, go to the tree. Yep. And I really want to create the yeast version. Yet, we'll get there. Okay, so note carefully. So we're going to create this one in dev. I'm going to let that run. So what you can basically do is you can create a separate stack, and technically you can use those for anything. You can use them for a different feature branch. You can use it for a different environment. For whatever reason, you would kind of want to have a separate version. Like I was saying, maybe if you want to have just release 52 has its own stack, and then you basically go back and delete release 51 before that. So you can basically go and say Pulumi. Oh, gotta make sure we're on our right directory here. Pulumi stack init, and we'll make a new one called prod. And I probably shouldn't do this while that other version's running, but then you would actually, while you're local, you would need to actually say Pulumi stack select, whichever one is active. And we didn't really dig into these earlier, but there's kind of these YAML config files that kind of go with each one. So let me get that out of the way. So this kind of contains the general project name, and kind of some other general things about the project, and then more specific variables. So in this case, we can actually specify a different variable. So these are kind of global ones specific to the provider. So you can kind of tell initially when we were saying what region we're going to be in, this is where it's being stored. So if we actually want to run that in a different environment, we can either set it in a different config file, or even when we're running the command line, there's basically ways to say, look, I want to actually override this variable and pass in a different value. So we could kind of run this in East US or something in production. I don't know why you would, but you could do that. So then basically, in our case where we made a new prod one, if we made a pulumi.prod.yaml file, it would kind of run that when prod was selected instead. And basically the way that you leverage that, so the basic variable is going to get leveraged underneath the covers when Azure's running its things. But the way that we get to that in our code is basically saying new config, config require. And there's a couple different options. You can say, I forget the other syntax, but there's one more where it will kind of more kind of assume a default, where you can kind of basically say if somebody doesn't say this, then kind of, because there's sometimes where you may not want to, you want to have more of a sensible default, like you don't want to force them to do it. So you could just say, like if they don't provide one, then just kind of automatically use locally redundant storage. But this is kind of more of a, if someone doesn't provide it, you need to basically fail at this level. So this does need to be required. So then basically, like you would in C#, you can just take this and now pass this into our variable instead of hard coding it. And then now this is more programmable. And you can kind of do this across the board. Any of these pieces can kind of be more programmable. And it's kind of your heart's desire at this point in time. I mean, this could be a Boolean. And you could basically say if for some reason, true, false, you don't even create this entire website. You could do something more complicated like that. Really, I mean, the sky's the limit at this point in time. Anything you could do in .NET, you could do in this environment as far as logic to create these things. So, I don't know if there's more show on that. Well, maybe, I think I've already had to pre-bake this one, but we'll kind of stop again, see if there's any questions at this point in time. Okay, anything?
Especially for the YAML files.
Mm-hmm.
One of the things that I struggle with is just blank following options. So
Mm-hmm.
what's the documentation like for what's available in
Yeah, so in general, so the question was kind of specifically around the documentation for the YAML file, but even in general, the question on that documentation, so the best place to go for almost all this stuff is the Pulumi website. So there are docs out here, and there are specific ones in each of the cloud providers, and there's also general concepts beyond that. So get the exact spot, but it's going to be around configuration. It's going to be on kind of that specific question. But then, yeah, if you actually go into the actual specific resources, and probably almost better to Google sometimes than to drill into some of these. But basically, you know those things like the storage accounts and things. There's going to be a page that's going to be, this is the storage account resource, and these are the 52 options that you can set on this, kind of the defaults, things like that. Now, I will mention, we were talking before about the classic versus the native. I think since I think they're kind of generating a lot of that from the API, at least at this point in time, the documentation on the native packages is a little leaner. I hope that kind of improves as time goes on. But yeah, as far as a lot of those options, generally Pulumi.com is going to be your best place to go for a lot of those things. But yeah, good question. So just as a brief setup for our next example. So we're going to slightly build this example a little more. We're going to build a 3-tier web application. So basically on the front end, it's going to be kind of our same static website, but instead of hosting regular HTML files, we're going to basically host a Blazor WebAssembly application. Kind of our middle application, or kind of our middle service tier is going to be in Azure Functions, and that's going to then rely on Cosmos DB. There's no technical reason it's a very cloud native stack. There's no technical reason you have to use that technology. You could easily have done this with SQL databases and Azure App Services. Just kind of wanted to show that you can write a very cloud native sort of stack using entirely C#. Plus, that's the other nice thing of flexing Blazor is that literally each of these pieces is written entirely in C#. Like there's no JavaScript, there's no extra JSON syntax you need to learn. It's kind of all C# from end to end. The other nice thing is that, since these are all running on my subscription, I am paying for all these things. So basically, there are free versions of all these things. So I also didn't want to spin up any super expensive, VMs or Kubernetes clusters or anything like that. But this is kind of the general setup for this application. Now, I did also kind of run Pulumi up on this ahead of time. This one does take the Cosmos DB one takes about 15 minutes to set up. So I kind of did the cooking show trick of creating it all ahead of time. We can kind of briefly go through that code. So the other nice thing is kind of a brief plug is that when you start creating a lot of infrastructure, it is good to generally tag these things, so to kind of categorize them. So, you know, at a bare minimum, generally what you at least want to kind of do is associate like what application this thing has to do with, what environment it is, whether or not it's dev, test, or production. Oh, and I forgot to update this example. We can kind of rearrange these demos. So basically, we already showed the stack instance. There we go. So this is kind of the neat thing too. Like I don't need to hard code that. I can basically say whatever stack I'm running in, basically set that as the tag for that environment. So if it's production, I'm going to automatically set that environment as production. Kind of who to charge for it, who's the owner. So generally it's best practices. It's kind of a separate from Pulumi. It's kind of more of an Azure best practice. But so now we're basically going to kind of leverage those tags throughout. But kind of the nice thing I want to show on this is that, you know, so here's all the stuff to set up the Cosmos DB database. We're not going to really jump super deep into any of this. It's kind of a somewhat lean example of what you need to do to set up Cosmos. We're going to put a database in there. We're going to set up a collection inside of there. And then we're going to get the connection string. And that's kind of the key thing I want to show, because then when we set up the function, it's going to need a reference to what that database is. And you figure this is normally something we would have had to manually set up, especially in these scenarios where we're kind of creating these on the fly and especially kind of coming up with random names. This is kind of the nice thing that you can stitch all this stuff together. So we're basically going to get this connection string. We're going to set up our app service plan. We're going to set up our, so Azure Functions, you have to have a storage account for it. We're going to set up our Azure function. And then in our config, we're going to basically put in the config a Mongo connection string, just kind of using the Mongo provider in Cosmos DB and passing in that connection string. So then kind of moving up another layer, now when we go ahead and set up our static web app, it's kind of going to need to be that same thing. When it calls out to an API to get its data, it's going to need to know where that URL is. So farther down. So now, yeah, here we're actually going to go out and do our same trick. We're going to go out and get all of our data. And there's probably, I'll explain this in a minute, but we're going to go out and get all of our data from a different project I have in here that has the Blazor app in it. Now, what I was going to say about that is, you know, traditionally, if kind of the infrastructure and the application were kind of on different release cycles, if you're only going to set the infrastructure once, but then the application is going to get updated every week, you probably wouldn't necessarily deploy the web application as part of the infrastructure. You'd probably have a separate release where you're just kind of, you know, kind of doing more of a traditional Azure deploy to just deploy the Blazor resources for that. But then what we're going to do is we're going to then create a JSON file and drop it into that static web app. And then what we're going to do is we're going to get our, where is it? Oh, yeah. So basically, here's our function app. We're going to get the host name and kind of do our string interpolation to drop that into the JSON file. That way, the JSON file kind of locally has or that way that Blazor app kind of locally has a reference to the Azure function. The Azure function then has a reference to the Cosmos database at the end of the day. And what's cool is that you can spin up, you can do this a bunch of different times. You could make a new stack. It's going to set up an entirely separate copy, and everything's going to have its own correct reference. You're not going to have to worry about keeping that separate production reference point to production, stage point to stage. You know, this infrastructure is going to handle all of that for you. Kind of some general helper methods, and that's the other nice thing too, right? Like there are a little bit of cleanup work to kind of format these the right way, just like we would in C#. We can kind of extract that logic out into a separate function. We can also kind of tell is that we are starting to get rather long in the tooth in some of these things. This is now 250 lines to define all this, and we'll kind of show that in the next example, how to kind of clean that up. But basically, when you pull me up and run all this and run in a little test data, we get our nice 3-tier application where this is now going out to our URL, kind of hitting functions and hitting Cosmos at the end of the day. It's kind of a fun fact. This application has now come full circle over the last 10 years. I made it originally in C# in Silverlight. Then Angular came along. I rewrote this application in Angular. I rewrote it in Angular 2, and I was like, I just need a real basic static website to kind of run, in Blazor. So now I rewrote it back into C# into Blazor. So now my Galactic Empire employee directory now runs and gets data. Oh no, what did I do? Oh, you know what? I bet that there is a new URL for this. I think I cached the wrong thing. Let's see here. That's what I get for trying to pre-bake some of this stuff ahead of time. Can't have my Galactic Empire thing not work. All right. Yeah, so I'm in the web account. Let's see. Where's my name? I'm not seeing. Oh, here we go. Oh, yep, I think that was the wrong name. That's a. I'm clearly doing something wrong. All right, I'm not going to worry about this too much, although I'm very, very sad. I spent way more time than what was really necessary building out that contrived example for like 30 seconds with a demo, but let me come to that later. Anyway, so that's kind of one of those nice things about building all that up, is that you can kind of build out that full stack of things in C# and kind of manage all those dependencies. And basically, if we were to spin up another copy, it would basically, you can tell I got all my tags here now too. But basically, it's going to keep all that in check, and I could tear all that down, and it's going to clean all that up. And all those resources are going to go away, and I'm not going to have to worry about them anymore. So what I was going to say is that, like we were saying, this is getting rather big. And in other things like Terraform, you do have to get a little more complicated as far as how to break some of those up. And here, it really is just kind of the way that you would normally break up C# code. I'll show a slightly more complicated example here in a minute, but really, it's just going to be the way you normally would do this. So we can basically take all of our Cosmos code and just put it in a separate class. So all that code that we kind of had before, it's just in Cosmos, and we're just kind of leverage a output. There is, and although this could be a string, there's some clever things that Pulumi can do as far as inputs and outputs, as far as kind of, knowing that it has to wait for the one thing over the other. So that is the one Pulumiism that you probably would want to lean to, as far as just defining these things as outputs and then sending those in as the inputs on the other end. But basically, other than that, I just copied and pasted all this code out, put my specific function there and kind of wrapped it inside of a class, put my Azure function code, kind of its own class, and put my static web app in its own class. And each of these is kind of taking in arguments for what it needs from the previous thing. So the static web app is going to need the API URL. It's going to need its tags. It's going to need the resource group names. And then in my main stack, this is now a lot leaner and meaner. I define my common tags in a high-level spot. And now I can just kind of say new Cosmos, kind of take the connection string from that, pass it into my function, pass it into a static web app. And that's also kind of abstracting all these common concepts now. So now really what's kind of the cool thing is that, I could generalize this a little more, but I now generally have a static website resource. If I want to make a different static website with different URL or with different parameters, I could do that. And that's kind of be the next kind of example we're going to show. So there is a concept in Pulumi called components. And that's really kind of more of that proper way to really kind of abstract these things as a logical thing. So if we can really kind of take all these, and we can wrap all of these in a concept. I should quit looking at the screen and looking at this. I got to remember it's right up here in front of me as well. But basically, you can write a component that will inherit from a Pulumi component, and it's going to basically do those same things that we had before. It's going to take in some general parameters. So in this case, we could just take in a general name and some tags. It'll take in some options, and it will do all those same things we did before. It will set up our Cosmos, our functions, and our static web app, and then it will kind of set its specific outputs. So in case we need those later on. And what's cool about this is that, you can kind of generally build this out as a model for how you would build a 3-tier web application. So if you want to build something for, in this case, managing the Empire's firm directory, you could just say new 3-tier component, pass in specific arguments, and generate that. then if you needed a separate 3-tier web application, you could just literally just take that component and re-leverage that and just kind of say, yeah, look, now I want another 3-tier component that now does this completely separate thing. So it's kind of that same way that you kind of, abstract some of those things away and kind of re-leverage those templates and those best practices like you would in .NET. Now, with that being said, if you're just kind of staying within the same language, so in this case, if we're always just within C#, you could just package this up and share it the way you normally would with like a NuGet package or a DLL. You could just basically say, here's a 3-tier component in our DLL, and then reference that in some other .NET application, and then kind of bring that in. So if your company kind of wanted to define, this is generally how we do, Azure Functions or Azure Static Web Apps, you could define that in a central place and share that amongst all your different, teams that need this, so you're not, reinventing that wheel every single time. Now, with that being said, though, there's kind of a separate concept in Pulumi that we don't really have time to get into. It's called packages. But basically, you can do that same type of thing, and there's a little more tooling involved to get that set up. Basically, what it does is when you run it through that process, it actually creates that type of resource for all the major languages. So you could write it in .NET as a package, and then it's actually going to make like the Go and the Python and like the TypeScript versions of that, and then different teams could use that in their specific language. So, I mean, you definitely want to do that if you're more of like an open source provider that is providing this general template that the world's going to use. But you could also use that even within your team if, certainly in one scenario, if you have a different team that just works more in TypeScript or something like that, that's more of a web team, or just in kind of a general way, if you just kind of want it generally available for whatever, programming language that someone wanted to pick up. So that's generally how you would kind of take these and kind of share these and build a lot of these templates up. Like I was saying, this would be a great case of where, if you did have standard conventions that you always wanted to have set, like you always wanted to have, HTTPS turned on, or, Azure AD. These are kind of these general ways you could build these bigger infrastructure building blocks and kind of share those around. Is there any general questions at this point? Check the chat here. I haven't checked in on there in a while. Not seeing anything. We'll move on, I guess. All right. I think that hopefully is everyone's completely sold on this, or just completely glazed over and checked out, one of the two. So, so with that being said, there are certainly going to be scenarios where, you've definitely started on that journey and started adopting Pulumi, and kind of the thing is that a couple of scenarios you could get into. There is a scenario where, there is this existing infrastructure that either you've created before this. This is definitely the scenario I ran into, right? There's all the stuff I manually created before I went to these things, and then now I need to bring that into the fold. So, in this example, let's go out and look. And so now there's something that, Jake, before he knew any better, went out and created a resource group with a different storage account that was manually created. And now I want to kind of bring that into the Pulumi fold. Basically, there are commands that you can run. Kind of just take this right here. And the main thing that you're going to need is it's going to rely on an ID inside of Azure. So everything in Azure has a big, long ID. And it's a little complicated to get that in the first place, but generally once you kind of figure that out, it's not super complicated. So let's go to our import example. That's about the only real complicated piece in this. So basically, this is the ID for this storage account. And I just need to get my subscription ID. Actually, I can get that from the portal. I don't think that is a secret sensitive information, but either way, don't do anything nefarious with my subscription ID. And make sure I got that account name right. I think that's right. Okay. That is. asked what stack I want to bring that into. What did I get here? Yeah, I was going to say, I knew that didn't look quite right. All right, we're going to kind of, good call on that though. Here, we're going to kind of, we'll do, there's my notes. I'll paste it into there first and fix it. Yep. There we go. One. Project name. Oh, is that actually case sensitive? That's what I was saying. Like, it'd be interesting if it was actually that picky. It might actually be. Huh, yep. All right, so what this is now going to doing is it's going out and looking at that resource that's manually created out in Azure. And so it's kind of picked up and said, oh yeah, I found this thing. You want to import it. And it's going to kind of bring it into that state file. And then as part of that, it's actually smart enough to kind of reverse engineer this code. And it will kind of spit it out. Where did it go? Yeah, that's odd. Anyway, what you probably typed in, probably somewhere in that gyration that we got a little confused already in there. But basically what it'll do is in the console, it will spit out the Pulumi code that's the equivalent of what was in Azure. So in really, it's going to look very similar to what we had in that first example. It was just a basic storage account. But it will basically generate out that C# code. And then what you do is you then take that and paste that back into your project and then kind of Pulumi up to kind of get that all back in sync again. So basically that's definitely a big step up over something like Terraform. Terraform, you can import that stuff, but you have to write all of that code manually by hand. There's kind of a way to kind of roughly get there, but for the most part, it's not going to kind of reverse engineer that code for you. So that's definitely a huge thing that I like about Pulumi. Beyond that, there's also, there are basically tools in both CLI tools and online tools that you can basically take code from other providers. So this is Terraform code that's going to do the same thing. And let's see. Yeah, there's a online editor as well for this, which is just kind of crazy. So you can basically take this Terraform code and just make TypeScript. We want it C# and we want it on, oh, nice, you even figured out it was Azure. And basically generated this into C# Pulumi code. So, you know, it's kind of another, you can tell that they've gotten really good at this because they can easily take existing Terraform code. You can also, and we'll kind of show this later, if there's other stuff that's been created by Terraform, it can kind of be aware of that and kind of, you know, interoperate with that. So you can definitely tell that they've gotten really good at interoperating with a lot of these existing stacks and generating this stuff. So, but that's kind of a way that, you know, if either someone else created something or kind of you had something previously, that you can kind of bring those into the fold and start moving things more towards Pulumi. Now, kind of the final case you're going to run in, that you could run into is that, you know, certainly if you get a little bigger and complex, you might be in certain scenarios where certain teams want to have control over certain things that you need to interoperate with, but you don't necessarily need to have control over. So certainly in the place that I used to be in, you know, there were just very core infrastructure things, you know, like a virtual network that needed to be there. And certainly I do not know enough about the virtual networking space that I shouldn't really be messing with that. But I do need to create things that live in that virtual network space. So, drop out of this. And, oh, ha. All right, here's my code. I don't know I don't know if there was a bit of a delay or I was just on a different PowerShell window. But yeah, this is basically when I ran Pulumi import. This is that code that it generated. And you can tell it's not smart enough to know what stuff is kind of the sensible defaults, because there's a lot of sensible defaults that either Azure or Pulumi will set. So you can tell it's slightly more verbose. So it does have a few more things in that our Hello World example didn't have. But in general, this is already our working C# code from the import. So just get back to that. So glad that actually worked and didn't make a liar out of me. But so let's assume in this example, and we'll kind of Pulumi up this first. Make sure I got that going. Okay. So there's some core infrastructure team that needs to set up a virtual network. Okay. So they've kind of set up their resource group. They've kind of set up their virtual network out there. And as part of that, it is important that they do set as outputs some of the core information about that virtual network. So they're setting the virtual network name and the subnet ID. That subnet ID is going to be very similar to that surge account name, where it's that big, long kind of subscription / resource group / virtual network / subnet ID. But if there's some other existing team that has that out there, and you're more of an application team, it doesn't really need to see that, but needs to interoperate with that. So you need to actually go and put your SQL database within that virtual network. Basically, as long as that is defined, and so now there's going to be that state file out there that's kind of defining this, that lives on, in this case, we're kind of using the Pulumi website as the storage for that. We can kind of get variables out of that and kind of piggyback off of that in our specific application. So kind of like how before we were kind of saying we want to require something from configuration, we can instead say, I want a stack reference. So I want to reference this other stack that some other team has created. So in this case, this is kind of the URL out to Pulumi, but you could just as easily reference it if you were using Azure Blob Storage or something else. So this is kind of the name of that project. And this is even kind of clever too. So even kind of using the respective stack name. So if there was more of a staging virtual network, I could have my staging account point to the staging virtual network. And then I'm going to go and look at the outputs that were defined in there to go and get the subnet ID. And then I can go ahead and take that in my application, create my SQL server, and then kind of set up a virtual network rule to basically allow things from that virtual network passing in that subnet ID. So then that's kind of ways that you can kind of slowly decompose and kind of build these things all up over time. So you kind of have more different teams building different pieces of infrastructure and still kind of standing on top of each other. So, certainly in cases where I've had a place where I've worked before is that, you kind of build up these layers. So sometimes you can just build, even like the SQL server, right? You might have one common SQL server, but then individual applications have individual databases on there. Or you might even have an existing database that multiple applications have to get to. There's definitely times where you're going to kind of have core pieces that some other team might define that you just need to reference in your particular application. And this is kind of the way to build that up.
We have one question. What are license costs versus Terraform?
Ah, great. I won't even try to make up what that is. I will just literally go to the Pulumi.com website and we will have that answered. So the question was around pricing. So this is where it is. Individual is always free. The team looks like it's almost based on the type of usage. So I think based by the number of kind of stacks and run states and things like that, that's kind of the way it is charged. So now with that being said, though, you don't have to buy into any of this. This is just kind of if you're using their website. So certainly if you are kind of using, like there's no charge for the Pulumi CLI. So basically if you store all of your state and kind of manage that in Azure Storage or some other type of storage, you're kind of independent of that entire world. Now there's a little more legwork that you need to do in those cases, but then you're just paying 8 cents a gigabyte or whatever for Azure Storage instead of necessarily paying for anything in Pulumi. But there is some features you're going to lose on that. But That's the general cost and probably the place to look it out. I am not a expert on some of this. Let's see. Managing one resource for 1 hour. Interesting. So that's how it goes. So apparently, I guess it's just based on the amount of things that you're actually creating in Pulumi. So I mean, that is a fairly small micro cent. So I imagine you could probably build a fairly large chunk of infrastructure for not a lot of money. Oh, and it does actually look like, oh yeah, you do get 150K free credits. So it does seem like you could get fairly far for not a lot of cost in a team environment. But yeah, it's a great question.
A resource would be like public IP, a storage disk, and all kinds of stuff.
I believe so. Yeah. So I mean, yeah, certainly in a bigger, and yes, it'd be an interesting question. I wonder if that in case where we're building out a blob, if actually every single blob is a individual resource that is getting managed out there, which might be another reason to actually, in that case, deploy your actual blobs as part of a separate deployment that's not part of Pulumi. And I should have mentioned as well in that case, it is smart enough to track differences in blobs if you have a file asset. So if we actually would have changed something in our index.html file and run Pulumi up, you would have actually realized that there was a diff in that file and upload that one and maybe not the other ones that needed to change. So once again, I should always run Pulumi up before I start talking. Actually pay that difference in there. But anyway, in general, what this is going to do is then create the database and kind of reference that that other variable from that existing Pulumi state. And the thing I was going to say as well is that it can pull in Pulumi state, but it can also actually pull in Terraform state as well. So if you create something with Terraform, you can actually point it to a Terraform state file. So if you have a different team that just for some reason really love Terraform and create that virtual network, you can still kind of interoperate with Pulumi there as well. So that probably will take a couple minutes. So we might just come back to that one. But yeah, are there any other questions at this point in time on any of that? Definitely some great questions so far. I'm not going to try to take another bite of my sandwich at this point.
Did you use Terraform for this?
Yeah, so more of my background is definitely in Terraform. That is primarily what I use. But yeah, this really is more researching Pulumi as of over the last several months. So but yeah, more of my familiarity is kind of where this compares and contrasts to Terraform. So some other things that we did not really have time to really get to as part of this. Like we were saying, packages, that was kind of that concept of being able to kind of bundle up a bunch of Terraform resources, or sorry, Pulumi resources, and kind of have that generated across all the different languages. Commands, so you didn't really see it as kind of something I set up ahead of time, but you figure there's kind of things that do just need to kind of happen in a one-off fashion. So in the case of the Cosmos DB, as part of an initial setup, I did have to load some dummy data in there, and that was kind of right now just done in a one-off kind of, C# script. So commands are kind of ways to kind of more, and certainly once you're in C#, you can kind of do anything once you're in there, but commands are kind of more of a structured way to kind of specify a one-off custom thing that you need to run and kind of tear down. So you can kind of imagine, especially things inside of, like a virtual machine or something you might want to set up as a one-off, or something in like databases that you can't really specify directly in Pulumi that you would kind of want to run as a one-off. You could kind of do those in commands. So generally the main thing you need to worry about then is that, you generally have to specify a opposite reaction. Interesting. So kind of, if you're going to set up a, user ID in SQL, you need to kind of have a corresponding opposite thing that's going to remove that user. Like we were kind of mentioning before as well, but, there's, ultimately the place you want to get to on a lot of this stuff is also running it through your general build pipeline. So something like Azure DevOps. So, then that way you're always kind of working from the same source. So, certainly a lot of your dev stuff, you can kind of spin up your own dev stack and kind of run individually. Once you're kind of really touching the production environment, especially since those state files are kind of shared across the board, that's kind of why they're in that general centralized location. You wouldn't want multiple things kind of running against there at once. So you kind of always want that running through a structured kind of build pipeline if you can. The other thing is multi-cloud or multi-cloud. So, I don't really see in practice a lot of people literally taking like the exact same application and saying, all right, I'm going to load balance. I'm going to run this thing in Azure and AWS and GCP and kind of load balance it across the board. I really don't see that in practice. Generally, there's more complexity than what that's really worth. But there are a lot of applications. Certainly you could imagine a scenario where, for other reasons, you're running different workloads. Like you're definitely running, this finance thing over on AWS, and for some other reason you're running this other thing on Azure. And it is nice to just kind of take those skills across the board from one application to another. You can kind of have those people and those skills more easily transfer from application to application. The other thing that I think you also see is that, although those things are kind of the general purpose massive cloud providers, there are also very specialized, kind of more niche things that are in that you do kind of set up as well. And I meant to show this earlier, just all of the package providers that are actually available in Pulumi. So the major ones are fairly obvious. It's not right. The thing is, I actually have the link on the next slide. I probably just stay on the slides. Registry. All right, so there are the major ones. There are also lots of more niche cloud providers as well. So you can certainly imagine there are lots of times where, certainly, I'm sure we're all in scenarios where our DNS provider may not necessarily be Azure. It might be something more like DN Simple or Network Solutions or something like that. Certainly, authentication, you might use something like Auth0. You might be in a case where you don't necessarily want to use Azure's Redis provider. You might actually want to use the true Redis provider from Redis Labs. So certainly in those scenarios, you really are spanning multiple cloud providers. You are kind of going in these niche solutions. So you're not actually having to pick up specialized tools in each case. You can just use Pulumi across that board. So yeah, certainly in that example, like even on our 3-tier example, we could have actually more used the true Mongo provider from MongoDB instead of Cosmos. So, and you can tell that there's just a truckload of stuff out there as far as other providers. And I think there's even kind of third-party ones as well. I think a lot of these are just more of the true packages that are from Pulumi. So yeah, there's just a lot of out there. Yeah, definitely feel free to check that out. I think there's even some that work for on-premise ones. There's VMware ones. So even if you do want to kind of span that a little bit and kind of cover those different cloud providers. But as far as learning more, like I was saying before, the main place you really want to go is to the Pulumi.com website. A lot of their main things, there's a general learn thing, all the major there's a good walkthrough for pretty much any sort of language or any major cloud provider you want to go to. The docs are really good. There's a lot of videos and just kind of, there's even kind of like a learning path it'll walk through where it'll kind of test you on some things. Like I was saying, there's the registry that shows all the different packages. And from there, you can kind of drill into the individual package you're looking for. It'll kind of have all the reference docs for that particular thing. And then there's just other general resources out there as well. Like I was saying, there's also the link to the presentation and all the slides at the bottom. And yeah, you're welcome to hit me up on Twitter as well.